What are the perspectives for innovation in grading and meat quality control systems, particularly in view of the production of entire males and immunocastrates? The working group Meat Quality of IPEMA had two main objectives. The first was to analyze the demand for a new grading system that goes further than lean meat content, by including traits that are important for eating and processing quality. The second one was to summarize the available information and the optimization of boar taint detection at or on the slaughter line. This presentation is a summary of a review report on meat quality grading systems and their potential for online use that will be published in a special issue of Animals. A review on rapid methods for boar taint detection has already been published in 2014. This was the final report of the EU-supported program BoarCheck. Moreover, a preliminary overview on meat quality grading systems and their potential for online use was presented in 2018 at the EEP annual meeting and published in a special issue of Advances in Animal Biosciences. The requirements for new meat quality grading systems were defined as follows. They need to be fast, usable online or at line, at speed line. They should be non-destructive and/or non-invasive. If possible, they should be automatic or semi-automatic. Their performance needs to be good. They must be accurate and precise enough to meet the industry requirements. They should be cost-effective, if possible, multi-uses, able to predict more than one quality trait. And it would be great if they would be correlated with consumer perception, which is probably the best gold standard or at least the most real one. Let's start with a quick overview of what's going on in the field of carcass and meat quality classification in slaughter plants. Carcass grading is performed online in most European slaughter plants because it is compulsory since 1989. Technologies that are used are based on vision, reflectance, ultrasounds or electromagnetism. The technologies or methodologies are fully automatic or semi-automatic, meaning that an operator applies the device to the carcass and the device makes the measurement and saves it automatically, or they are fully manual. All the technologies are used online, that is that they are fast enough to follow the line speed. Fully manual technologies can be used only in small abattoirs with low-speed lines. In carcass classification, the result obtained is the lean content in the whole carcass, which is defined differently depending on the country. More information could be obtained with some of the devices to have information about the weight and lean content of the various cuts. Regarding meat quality grading, or work carried out within another cost action, FAIM, review the imaging and spectroscopic technologies that can be used to determine meat quality in a non-destructive way. Some of these technologies have a good potential for online use. However, more work is needed. 1. To avoid or minimize pre-treatment of the samples. 2. To allow a continuous measurement in the carcass or the meat. 3. To speed up the measurements to match line speed, and 4. To address other challenges that must be overcome before implementation in industrial conditions can be envisaged. As far as we know, near-infrared spectroscopy or NIRS is the only technology that is used online in abattoirs. In Switzerland, quality classification, based on iodine value, is carried out at line with an NIRS device and used to pay the producers according to national rules. In other countries, iodine value is measured online with NITFOM, a portable device based on NIRS technology. To our knowledge, boar taint is the only other meat quality characteristic that is monitored for industrial quality control at slaughter plant. Regarding the assessment of boar taint, at or on the slaughter line, we focus the review on the methodologies already used to determine boar taint online at slaughter plants, that is the human nose and the colorimetric method. Technologies that have potential to be used online and have progressed after the BoarCheck review in 2014, or new technologies that have emerged during the last 6 years. laser diode, thermal desorption, ion source, tandem mass spectrometry, LDTDMS/MS, electromechanical biosensors, Raman spectrometry, and rapid evaporative ionization mass spectroscopy, or EIMS. Human nose is a sensory evaluation of ball taint. The other methods are instrumental. The colorimetric method, LDTDMS, and electromechanical biosensors directly measure scatol, or both androstenone and scatol. Raman spectrometry and REIMS measure lipid composition profile, which is claimed to be correlated with ball taint. In the deliverable of this work group, these technologies have been explained, and a SWOT analysis, that is, analysis of strengths, weaknesses, opportunities, and threats, has been performed for each of them. No legislation regarding this classification is available, although there is an EU regulation, Regulation number 854 from 2004, that states that meat with a pronounced sexual odor is unfit for consumption. An analytical sensory evaluation of ball taint, performed by sensitive and trained assessors, classifiers, is known as human nose, and can be performed online, as you can see in this video or at line as in the photo. It is used in several slaughter plants in different EU countries, such as the Netherlands, Germany, Belgium, Denmark, France, and Spain. That need to be heated, and there are different methodologies to do it. The most used online is the gas-powered, Bosch heated plate. The method is a direct assessment of ball taint, and it classifies carcasses usually as tainted or non-tainted. In some cases, the users scale with different degrees of taint. The cutoff used to decide if a carcass is tainted or not can be variable. The cutoff is determined by comparison to a gold standard, which can be the average panel score, or the levels of androstenone and scatol determined chemically. The performance of this method is highly variable from one assessor to another. A good selection and training of the assessors and regular evaluation and documentation of their performance are therefore critical to identify suitable assessors and to have an accurate, efficient, and reliable panel. The performance of this method is highly variable from one assessor to another. A good selection and training of the assessors and regular evaluation and documentation of their performance are therefore critical to identify suitable assessors and to have an accurate, efficient, and reliable panel. Starting in the early 90s, Danish slaughter plants used the colorimetric method to sort out carcasses with high scatol levels. This methodology is now mostly discontinued. It should be replaced shortly by the LDTDMS method, which measures both androstenone and scatol. The LDTDMS/MS method recently emerged in the market. It arises as a very promising technology that should be introduced shortly in Danish slaughter plants. This technology measures androstenone and scatol directly. It is offered by Shimadzu and the Danish Technological Institute. It allows an analysis in less than 10 seconds, excluding the sampling and sample preparation time. The Danish solution also offers the possibility to automatize sampling and sample pre-treatment, allowing up to 420 samples per hour, and a delay of 40 minutes from sampling to result. The cost of consumables is around €1 per sample. This does not include costs for personnel, maintenance, and depreciation of the investment. Thus, it can be a good solution for objective androstenone and scatol determination online. Because the investment costs are high and must be depreciated on a very high number of carcasses, this methodology can be envisaged only in large slaughter plants. Then, it would be the decision of the slaughter plants to choose the cut-off levels to sort out tainted carcasses according to consumers' demands, the prevalence of tainted carcasses, and the risk they are prepared to take. The University of West England is working on an electrochemical biosensor system, which is a potential technology for the mid to long-term future. The technology measures androstenone and scatol directly. It is used directly on the carcass, so that no sampling is needed. The sensors are disposable, thus avoiding cross-contamination. The methodology still needs some improvement to be used online in slaughter plants. The aim is to use an automated static device, or manual portable one. Significant progress has been made during the last years, but the performance of the biosensors in industrial conditions is not available yet. Some other possible technologies that could be considered in the mid to long-term future are the Raman spectroscopy and the IRTA. These technologies measure lipid composition or lipid unsaturation, which are claimed to be correlated to androstenone and scatol levels. Raman spectroscopy has the possibility to use a handheld device. The acquisition time should be reduced in order to be able to use it at slaughter plant level. IRTA has been proved at lab level and recently at slaughter plant level at line. It allows a classification of carcasses as tainted and non-tainted. Because the measurement is indirect, a calibration is needed via statistical relationships with fatty acid composition of the tissue. This will be very difficult in commercial slaughterhouse conditions, where pigs from different genotypes are coming from different farms and receiving diets differing in their fatty acid composition. Performance in industrial conditions is still unknown. Improvements are still needed before any use at slaughter plant level can be envisaged. Thank you very much for your attention.